So, Pythagorean theorem. We should know Pythagorean theorem from pre-algebra, correct?
I don't remember it. I remember the name.
Right. So, Pythagorean theorem only works for right triangles, so make sure you underline that. It has to be a right triangle. How do I know if it's a right triangle?
It has a 90-degree angle.
It has a 90-degree angle, which is represented by the little square in the corner. If the triangle does not have that, you may not assume that it is a right triangle. Even if it looks like a right triangle, if it does not have the box, you cannot assume that it is one. Okay, so you can only use Pythagorean theorem on triangles with the little box that are right triangles. And you all should remember this. If my legs are A and B, and my hypotenuse is C, do you guys remember that? Leg, hypotenuse. What is the formula? A squared plus B squared equals C squared. Write that nice and big in that box.
I remember it now.
So example 1. Here's a right triangle. The legs are 8 and 6. We want to find the length of the missing side, which in this case is the hypotenuse, C. So I'm going to label it C. So let's plug these into the formula. 8 squared plus 6 squared equals C squared. What is 8 squared? 64. What's 6 squared?
36.
Equals C squared. So we add them. What does that give me? 100 equals C squared. And have I solved for C yet? No. What do I have to do? Take the square root. Okay, so square root of C squared is what?
10.
Square root of C squared is C. Square root of 100 is 10.
Oh. This is a lot easier.
Well, whatever you do to one side, you have to do to the other. Example 2. Alright, I have 3 and 5, and I'm missing this part right here. What is this missing part? Is it a leg or the hypotenuse? It's a leg, so let's label it A. So this time my formula is going to be a little different. I don't know what A is, so that's going to go into A squared plus B squared. What's B? 3. Equals C, which is 5. So equals 5 squared. The hypotenuse is always the one that's across from the right angle. Okay, so the one diagonal from the right angle. Okay, A squared, we don't know what it is, so we have to leave it. Plus what? 9 equals 25. Okay, now what? Subtract 9. So that gives me A squared equals 16. So then what?
4.
Square root.
4 times 4.
So A equals 4.
I got that right.
So now, same idea, but we're going to take it one step further because we are Algebra 1, right?
Wait, what? Square right there.
Okay, it was a mistake. Okay, so what part am I missing?
Hypotenuse.
Hypotenuse, so C. So A squared, 3, plus B squared, 3, equals C squared. What's 3 squared?
6. No, 9.
9. So 9 plus 9 equals C squared. 18 equals C squared. And then what? Square root. So C equals, can I take the square root of 18? No, but can I simplify it? Yeah, how does 18 break up? 9 and 2. And what's the square root of 9? 3. So that is 3 root 2. Is that okay? Yeah, it's totally okay. So your answer is 3 root 2. So now we're taking what we learned in pre-algebra, where it always worked out, to one step further in algebra, where we have to leave our answer as a root. Okay? Okay, what I want you all to do is try example 4 by yourself. Now, when I typed this out, obviously there was a typo that I didn't realize. That box should be down here. Okay, so you need to find the length of this leg or hypotenuse?
Leg.
Leg. So what do you guys want to call it, A or B?
B.
Let's call it B. Okay. So find the length of B for me. Okay, let me see. Alyssa, will you plug this into Pythagorean theorem for me? 12 squared plus B squared equals 13 squared. Good. Everybody should know this by now. What's 12 squared? 144 plus B squared equals?
169.
Very good. 169. Okay, what's next, Colton?
You subtract 144.
Good. I subtract 144 from both sides. And you guys, what does that give me? B squared equals? 25. Okay. Macy, what's my next step? I take the square root of both sides with a radical. Everybody, square root of B squared is? B. And square root of 25 is? 5. Good job. Okay, example. 5. What part am I missing, a leg or a hypotenuse? A leg. Do you want to call it A or B? B? Okay, sure. It doesn't really matter. Okay, so let's plug it in. What's A?
8.
Square root 3. So this is square root 3 squared plus B squared equals 8 squared. Is everybody okay with that? Okay. What is the square root of 3 squared? Square root of 3 times square root of 3?
9. No.
Oh my goodness, guys. Okay. Square root of 3 squared is equal to square root of 3 times square root of 3, which means the square root of 3 times 3, right? Which is the square root of 9, which is, oh my gosh, 3. Just a number inside. Okay? So 3 plus B squared equals 64. Okay, now what? Subtract the 3. So B squared equals 61. And then what? Square root both sides. So B equals... Can I take the square root of 61 or break it down at all? No, so it's just B equals square root 61. Okay. Okay, example 6, you guys lucked out because if you notice, they're the same. And I couldn't remember what I put originally, so we're just going to do the first two. Okay. Alright. So, let me read you the instructions and then we'll figure out what it is we need to do. Find the length of the side not given for a right triangle. So can I assume it's a right triangle? Yes. With a hypotenuse C and legs A and B. Okay, so let's do, actually I want you guys to do both of them by yourselves. They tell you A, B, and C, so you need to find the missing one. Okay, so the first one. Can somebody, Destiny, can you tell me how you plugged it in? Oh. Good. 9 squared plus 12 squared equals C squared. Everybody should be able to tell me this. What's 9 squared? 81 plus 144 equals C squared. And what is 81 plus 144? 225 equals C squared. Okay. Keely, what's next? I square root both sides. So that gives me C equals 15. 9 times 25, both of which are perfect squares, right?
Don't you have to...
Kylie, how did you plug in this part?
3 plus B squared equals
Very good. 3 squared plus b squared equals 4 squared. 3 squared is? Whoa. 9. Plus b squared equals 16. Subtract 9. So b squared equals 7. And then tell me, what do I do? Square root. So b equals root 7. Who got both of these correct? Excellent. That is Pythagorean theorem, ladies and gentlemen.
Now, does it work, Colin?